Yes, students. So now the part 2 of Unit 3. Okay, so we will discuss register transfer. So this diagram is basically used for register transfer. So how the data are being transferred with registers to bus, like that we will discuss. So for registers we need some control signals. Okay, so to transfer the data, so we need a control signals, so which is given in this input ri in. So this ri in is used for control signals, and ri out is used for both ri in and ri out are used for control signals, that is for being transfer the data, that is the register data from input to output, so control signals. So if this ri in, okay, if this ri in is set to 1, then what happens, the data on the bus are loaded in register ri. So how the data are being loaded, by giving the signal as ri in 1. Okay, so if ri out is set to 1, ri out is set to 1, then what happens, the contents of register ri are placed on the bus. See, for ri1 the data are placing here, and for ri1 out the data are sent to bus. Okay, so when ri out, now if ri out is equal to 0, the bus can transfer the data from other registers, means we are giving chance to other register to transfer. So I hope you have cleared in this ri in is equal to 1. So what happens if ri in 1, so ri in 1 the datas are loaded in ri register. Ri out is equal to 1. What happens, the contents of register ri are placed on the bus to do the process. If ri out is equal to 0, giving chance for other registers to work, or just we are stopping the transaction. So this is the operation, this is the things with register transfer. Now if you see, okay, so how the arithmetic and logical operations are performed using this registers. So if you see, as we already saw, ALU, our arithmetic logic unit, plays major role to transfer data. So the operands. So for example, you say we are having two operands. So from the multiplexer. So just you everyone know what is a multiplexer. So multiplexers so used to get the data. So so we are using this mux and bus for transferring and getting data. So the result is temporarily stored in register Z. See, you can see here the register Z. So what is the purpose of register is, it is a temporary register. So in the introduction itself we saw temporary registers are used. So in this temporary registers we are storing the results. So and then what happens, so that if we want to transfer the values r1 to r2 and the results are stored in r3. So what we will do means, so we will see here. See, we will see here r1 out comma y in. I will explain you with the help of this diagram. So r1 out comma y in. So this instruction, see, r1 out. So here this value of r1 will be moved. So in step 1 what happens, the register r1 and the input of register y both are enabled. Okay, this ri register, okay, r1 register and y registers are enabled in step 1. Fine, this is the step 1. Both the registers are enabled, and then the contents of r1 are transferred over the bus y. So the contents of register r1, so we need a bus to transfer. So all these contents are transferred to bus via bus y. So what happens for this in r2? So r2, this is r2 out, select y, add comma in. So what is meaning of this? So in what happened, the multiplexer, as I said you, we are using multiplexer and bus. So the multiplexer selects the signal y. Okay, the multiplexers will select this signal y. So this is a signal. So this signal will be selected, and where the contents of register y are input to the arithmetic logic unit. Okay, so this values and the y contents are given here to arithmetic logic unit. So this and this are given here. Okay, so this is the meaning of these lines. Okay, r2 out, select y, add comma z in. So this is the meaning of these two lines. So it's very simple. You just see, you can see in this diagram, you can see, so that contents, okay, that multiplexer content, okay, multiplexer content, and then the contents of Y are given to arithmetic logic unit. So parallelly what happens, the register R2. So we are having a value in R2 are now given to the bus, and they are given as an input value, input to B. This here see, it is parallel process, this one. So A it's getting these values. Okay, so A it getting multiplexed value, Y value, and parallelly what happens in B, so the contents of register R2 are given to input as B here. This is a simple test. Then what happens, the functions. So what are the functions performed by ALU, whatever arithmetic operations that is being performed, and the result, okay, the sum of these two values are like from input, some A will be having some 5 and B will be having some 2, then the answer is 7, right? So that values are added to Z register. Okay, Z register will be having now the value as 7, because as we are assumed that A is having the value 5 and B is having the value 2. We are doing add operation. Okay, after the addition, that value Z will be having the values. Okay, the content of register Z are then transferred to register R3 finally. So we discussed initially, right? So we discussed initially we are using two registers, three registers, R1, R2 and R3. So in this way, it is being performed. See, this final instruction Z out R3 in will be having the value of final result. Okay, so we have taken simple addition operation and we have performed this value like this, and these are the sequences. So sequences of operations. So R1 out comma Y in, so we are getting two values, and then R2 out select Y, add comma Z in, the help of multiplexes. Here we saw multiplexes are there, and we are getting another value B here. Okay, so parallelly, and that is for R2. So R1 we are getting value here, for R2 we are getting value, and finally R3 it is stored here. This is simple understanding of this arithmetic operation. Okay, so I hope everyone understand this. So we are moving to next topic. So next topic is very easy topic. So how we are fetching a word from the memory. So how to fetch a word from the memory. So what we need for that. So to fetch a word from memory, the processor need to know the memory locations. First, what you need to know? You need to know memory location. Am I correct? So okay, yeah, first that is my need to know memory location, and then where the information and what is the operation and what to be performed. So who will be who will be having this? So memory location will be in MAR, memory address register. Okay, memory address register will have the address of the location, like which instruction we need to fetch. Okay, we have completed this memory address location fetching. After that, what I need to do? I need data, right? So I have address. In the address, we need data. So for that, we need a what we want. We need a data register, that is memory data register, MDR. So which is used to transfer the registers, that is other registers, to processes. So you can see here, so MDR out and MDR in. So MDR in, so memory so everything. So from here we are, that is from memory data in means the data are given to memory data registers. Memory data out means the from memory data registers it is given to address lines. So similarly for both internal process bus and memory data bus, we are having the same operations. Okay, so this is, in this way we are fetching a word from memory. I will revise once again. So we in how to fetch, how we are fetching a word from memory. So what we need for that, we need a memory location. So where I will get the memory location? So the processor needs to transfer the address to memory using MAR. So MAR, memory address registers. After getting the memory address, if you want to add means if you want to read a particular data, where you will go and read, you will use this MDR memory data registers. So this is parallel, you can see this diagram how it is being transferred. Okay, so it has 4 control signals. So these are nothing but MDR in, MDR out, right? MDR in, MDR out, like that we are. And then connections for internal bus. So if it is connected with internal bus, MDR in, MDR in E, MDR out E, MDR in E and MDR out E, it is connected. Okay, so like that it is being connected. With the help of 4 control signals only, this MDR register transfers the data. Okay, so it's again given the diagrams. So this is a help, this is a steps, how we'll see with the steps. So as I already told you, so memory address register will be having that register value. So we want to move the values R2 and R1.